Hey everyone, welcome back to another Fusion tutorial. Today we are going to make a sprinkler head or sprinkler adapter for a garden hose, and I will use this to water my garden beds and some potted plants for my wife. The water gun, or whatever you call it, little water attachment I have for my hose, I'm not really a fan of. I almost always use the shower setting, so I figured why not make a dedicated shower attachment. So we are going to start this model not quite from scratch. We are going to use a model I've shown on this channel previously, and this is my parametric cap model. So here you can see I have it, and I have actually put in my parameters already just to save some time. You can download this model on Maker World. My username is dfreshkramer. You can find it right here. I will also link it in the description. And when you download this, there's nothing actually to print. You actually download STL CAD files right here, and there is a Fusion file that you can open up the Fusion file in Fusion. That made a lot of sense. So once you get it into Fusion, once you open up that file, you'll start with something like this. And you're going to want to go into change parameters. Now, if you don't have this button, you can go to modify down to change parameters. And I have a whole video on, I believe, not only how I made this cap, but actually how you get these measurements and stuff like that from your bottle. Now, you can actually look up what the standard thread sizes for garden, 3/4 inch garden hoses, and I had to tweak those a little bit. I am going to be printing this out of TPU for AMS from Bamboo Labs, so it's a little harder than the regular TPU. I don't remember the numbers off the top of my head, but it's a little stiffer, but it still has some give, and I thought that would work well for making this watertight. So I'm going to leave these numbers, the correct numbers, in the description of this video. I forgot my little cheat sheet, and so I don't know if these are exactly correct, but I think they're pretty close. So I've got the major diameter 26.2, minor 24.5. The pitch is for sure correct. So the pitch of a garden hose thread is 2.2. And then you can change things like wall thickness and all sorts of stuff. So that will be your starting point. So here is the starting point of our adapter. And so from here, we have to try and turn this into a garden hose adapter. And I have a little cutaway here that we'll be using quite a bit so we can see what we're going to do. So first, let's create a hole here, right? If we're going to screw this onto a garden hose, we need a hole here. So I'm going to click on that profile, and I'm going to go to create sketch. And then I'm going to hit P on the keyboard for project. And I want to make sure the specified entities is selected, not the bodies. And you can leave projection link checked. And I'm just going to click on that surface and hit OK. From here, we can hide the body. So we're just left with the outline or the sketch of that profile. And I'm going to hit C for circle. And we're going to make a circle roughly 17 inches. So the opening on a standard 3/4 inch hose adapter is between 16 and 18 millimeters. So this will keep the correct flow from the hose. It won't act like a bottleneck more than any other adapter, I guess. And so I'm going to finish sketch, turn the body back on, click that circle we just created, hit E for extrude, and just extrude it downwards so it cuts it away. Now, I'm not going to go into printing a TPU gasket here. I actually have tons of old hose adapters with those little black or white adapters. So I'm just going to use a store-bought one. You can actually find them on Amazon for super cheap, or a hardware store. So I'm going to use that in my model. Not everything needs to be 3D printed, especially when I have a real rubber one. So that's why we can't make this hole any bigger, because we have to save room for that gasket. So let's get analysis back on, and we are going to create a sketch now to make the outside of this sprinkler head. So I'm going to create sketch, and we're going to create a sketch right on this plane here. And if you don't have a nice 2D view here, you can go down to camera, and make sure you're on orthographic, and that'll just make this image flat and square, and it'll be easier to draw things. So we're going to go up to Create, Project, Include, and Intersect. And basically what this does, I'm going to turn my analysis off. Our plane runs through, our sketch plane runs through right through the middle of this body. And by selecting bodies this time and then clicking on this body, you can see what happens. It projected that body on my plane. So basically split that body along the plane and created a sketch from it. So we can turn that body off again, and now we have the middle of our adapter here that we can draw the shape of our sprinkler head and then revolve it. So all of these measurements are going to be arbitrary. You can kind of make them however you want, but I'm going to start with just a center line, and I'm going to hit X on the keyboard to make it a construction line. And I'm just going to go up maybe like, I don't know, like 2 inches. It could be less than that. And now we have to make the shape that we can revolve. So let me just bring this over this way. We're just going to work on the left side here. And we know I know that I want, how I made it before in the video I'll show you at the end, is that I want this to be about 3 inches at the top here. So flared out to about 3 inches. So I'm going to hit L on the keyboard, hit X again to take it off construction line. And I'm just going to make it about, it's not going to quite be 3 inches, about 34. That'll give me about 68, just a little under 3 inches. And again, you can make this whatever size you want. And then I'm going to draw another line that connects right here. Now, of course, we want this to be open. This can't be solid. So we kind of have to just draw the walls of our outline here. So I'm going to select these 2 lines and use the offset tool, and we're going to do like -2 millimeters. So we'll have 2 millimeter walls here. Now, if you think about how this will print, if you can visualize this, this side right here will be face down on the 3D printer, right? So then we won't have to have this massive overhang here with a bunch of supports. So as it starts printing up this way, this area is going to be a problem, and we're going to have an overhang right here. So instead of this line, we kind of want this line to come in this way. So what I'm going to do is just draw another line, and we're going to make a nice bevel here. So instead of starting from here, I'm just going to start here. This will all make sense, hopefully, as we continue and draw this line here. And then we can actually delete this line. We don't need that line. And we don't have this closed off yet because we need a line right here. And now it turned a shade of blue, which means we've enclosed the shape. So now it's a profile. And we can kind of test from here. This actually might be all we need at this point. I do know that eventually I'm going to want to strengthen this corner. If you think about the water is going to come through here and just push on this surface really hard. And so we really want to make sure this connection here is solid. Otherwise, you're going to get water. It's just going to break and you're going to get water leaking out. So we will, once we turn this into a solid body, we'll kind of address this area. I believe that might be all we need. So let's finish sketch. I'm going to turn my original cap body back on. And now we're just going to revolve this. So you can go right here to the revolve tool. If you don't see it, you can go into create and then revolve right here. Since I clicked on this before hitting the tool, it's already selected. So once selected, our axis is going to be this center line here. And I'm just going to turn analysis back on real quick so we can see what's happening. And we can hit join. We want it to join with our cap that we already had. And I'm just going to hit OK. Now, I don't want this ledge here. And so when I created that sketch, we had this little bit here that now we can cut away. So we can do the same thing with the revolve command. So select that profile, go to Revolve, and our center axis, our axis is here. And now it's going to be automatically set to cut since there's already a solid body there, and we can just hit OK. And now it just kind of cut that area away. Let's hide the sketch. And that's looking kind of cool. So let's turn analysis off, and there is our basic shape. And now this is kind of the cool part. I wanted a really nice pattern for the holes here. And so I actually asked ChatGPT how I should draw this pattern to have a good spacing of holes. And it just popped out this awesome math for me and did it. So we're going to now draw the pattern of holes on this outside. And so I'm going to click on this surface and create sketch. I always like to project the surface I'm working on. That way I can hide the body and I don't have to have that red or that body in the way. And now we're going to draw a circle. I've printed a few of these, and at first I started with 1 millimeter holes, and it did not print well. All the holes were closed up. 1.5 was better, but still not great. So I settled on 1.75, and that gave me a pretty good hole opening for the water to shoot out. And so that's what we're going to stick with here. I wouldn't go any, unless at least for TPU for AMS, that worked really great. I'm not sure what will work for with ASA or ABS or PETG. You'd have to test that out. So now we basically want to draw a line of circles here that we can then pattern around. And so I'm going to take this circle. We're going to create a rectangular pattern going this way. And instead of extent, we want to do spacing. And I believe we're going to space this every 10 millimeters. So our spacing will be 10 millimeters. I'm sorry. That's going to be the diameter from this circle to this circle. So it's actually 5 millimeters. And let's see how many we're going to do. We can do that many, because remember we have a wall here, so we can't go all the way out to the edge. So let's do that. We'll hit OK. And so now what we can do is then pattern each one of these around the circle. So we can click on this first circle and hit create circular pattern. And this is where ChatGPT really helped. So first it told me the spacing, and then it told me how many in each row. So we're basically going to start with 6, and then we're going to add 6 every time. So 12, 18, 24, and so on. So I'm going to speed this part of the video up. I'll do a few and then speed the rest up, so it's not you don't have to watch me do this. So I'm going to click, we already have the circle selected, so I'm going to, center point will be right here, and we're going to start with 6 of them. Hit OK. Now I'm going to click on this circle and hit create circular pattern. The center point is here again, and I can just type in 12. Hit OK. And again, I'm just going to go through this. The next one will be 18, 24, 30, 36. All right, so there is our hole pattern, and I would have not figured that out on my own, so thank God for ChatGPT. So from here, we can finish sketch. Let's turn our body back on, and you can kind of see what that'll look like. So here's where we have some choices, and full disclosure, I actually printed this model first. So the video of it working at the end, I actually did before I actually made this tutorial. So the way I cut out these holes is as follows. So I want to select all of these holes and then basically just extrude them down. So select a circle, hit E for extrude, and then drag it down so it cuts away, right? If we turn analysis on, oops, looks like it cut that circle out, but you get the point. Then we have all of our holes here. Now I'm going to go backwards a little bit because there's definitely an easier way to do that instead of selecting each hole individually. And did I just get rid of, I'm going to Control Z. I went back too far here. I deleted my sketch. So let's turn that sketch back on and then just delete that extrude. So what you can do is select everything but the holes go up to Select, Selection Tools, and Invert Selection. And now all of those holes are selected. And we can hit E for Extrude, and we'll just extrude this down like 3, because I think we have a 2 wall thickness, 2 millimeter wall thickness. Okay, let's do analysis, and now you can see all of those holes cut out. Now this will cause all the water, and again, this is how I did it. This will cause all the water to shoot straight. So even these edges will shoot straight forward. If you wanted to angle these, so the middle ones shot, so these center ones shot straight forward, but then all of these other holes kind of started angling outwards, so you get a much bigger fan, you have to do it a different way. And it will take a little bit more time because I don't think you can select all the circles at once, but we're going to try it because I haven't tested it. So let's just turn analysis off. We're going to go back in time on the timeline to get rid of that extrusion. And let's turn on this sketch, and we're going to do the same thing. We're going to select the inverse. And now what we can do, hopefully, is loft it. So we're going to create loft. We want to turn the origin on, and we're going to loft it to the origin here. So I'm just going to click origin, and we have a whole mess. It's connecting all of them together. You see how it's making like a swirl pattern here? It's connecting all of them together and then going to the center point. Now, I don't know if there's a way around this. I suppose, let's see if we can just go up to loft here and just start clicking a few. See how it's making more profiles? I don't know how to keep all of these profiles as one. I don't think there is a way. So what you actually have to do, and I thought we'd need to do this, is you have to select each individual circle at once. So I'm going to select this one, create loft, down to this, and then hit OK. Now if I hide that sketch, this one should be pretty much straight down because it lofted that profile straight to the origin. Now if we select one over here, we turn the sketch on, I'll select this circle, and we can right click and repeat loft, and then select the origin. You see how that's cutting this way, and hit OK. And I'll turn that sketch off. And now this one is getting lofted to the origin, and it's at an angle. So if you wanted to do it this way, you would have to select each individual circle one at a time. And I'm not going to do that for this video. I'm just going to go back to what I did previously, but that would be the way to get a bigger fan pattern. So let me go back. I'm going to get rid of these lofts. Delete. And now we're going to do the same thing we did before. Select everything but the circle. Invert selection. E for extrude. And I'm going to do like -3. And OK. All right. So now it's really just cleaning up stuff. So I told you before, we really want to beef up this end. And I might have gotten a little too close for these. I think in my last, when I made this earlier, before this video, these were a lot thinner before. And so I think all I'm going to do is just add a chamfer up to the point of that circle. So 0.5, that seems pretty good. 0.4. That way that chamfer just butts right up to that circle. Hit OK. That strengthens it a little bit. And we can put a chamfer here. So this is not a sharp edge. I'm just going to do it with all these in one. So I'm going to click back on that first chamfer. Instead of doing a chamfer for every single edge, I'm just going to hit this plus sign. We'll do maybe like a 1 millimeter chamfer here. Let's just go 1. Hit OK. Actually, I would rather that be straighter here. So I'm going to click back on this one. We're going to do distance and angle for this chamfer, and we can angle this up to 90 degrees. Then it's nice and straight, and hit OK. And it'll still print perfectly fine, because remember, this side is going to be on the bed. So it'll print all the way up, and it should be able to do this transition really easily. And we can chamfer the outside. Let's get back into that. Hit plus. We'll do maybe like a 0.5 on these. I'm going to take that down to a 0.3, so there's just trying to get the sharp edge off. And we'll do another one. We'll do like a 1 millimeter chamfer here. And hit OK. So you could do all sorts. You know what? I might chamfer this again. I'm going to open up chamfer. I might chamfer this edge again, so it's a little bit. Let's see what that does to the inside. Let me hit cancel. Sorry, I just want to make sure this edge stays. I may go back into this one and do distance and angle. Quite like that. There we go, something like that. That's better. Okay. I think when I initially, on the first one that you're going to see at the end of this video, when I made that first, what sketch are we on? When I made this sketch, I actually had this line come straight down a little first and then come over, so I didn't have it go into a point. I think that's what was confusing me here. But that's okay. This will work too. Again, you make this design however you want. From here you could add texture to the side or some grips for turning it on, but that's pretty much it. We've got our sprayer, and I'm gonna go ahead and hit print on the well, I'm lying to you guys now. I've already printed this. I'm gonna show you in the next video of me taking it off the printer, and then I'll show you guys how I use it and how it works. So I hope you enjoyed this. I know it was kind of long-winded here. And I guess I don't know how interesting this is for people, but you definitely can print things like this and they work just fine. If you do print something like this, I'm going to leave the link to this file or my original file on MakerWorld so you can download it and print it yourself. I have not tested it in any other plastic other than TPU for AMS. So I know for sure it'll work with that. The threads will fit on the hose great. If you do decide to print it in a different plastic, leave me a comment and let me know how it fits. And if you print it out of like PLA or ASA and you have to tweak the settings a little bit, leave a print profile so other people can print in different plastics as well. So, all right, guys, hope you enjoyed, and we'll see you on the next one.